our first example on symmetry asks, how many lines of symmetry does a regular quadrilateral have? Regular quadrilateral means that all sides and angles are congruent, so in other words, we're referring to a square. So I'm going to get my line tool, and lines of symmetry are imaginary lines that you could fold the image and have both halves match exactly. So if I draw an imaginary line here, that would cut the square in half. I can draw another line here horizontally, which will cut the square in half. And I can draw a line diagonally and going the other way diagonally. So putting all of those together, I have a total of 4 lines of symmetry. And I'll pull them out so you can see. Here's 1 line, 2 line, 3 lines, and 4 lines of symmetry. So the rule is that a figure will have as many lines of symmetry as number of sides if it's a regular figure. So without drawing a nonagon, a regular nonagon, I'd like for you to answer the question, how many lines of symmetry does a regular nonagon have? Pause the video and see if you get the same answer as I do. So you should have gotten 9. 1, you had to know that a nonagon is a 9-sided polygon. And 2, you had to know that a polygon has as many lines of symmetry as number of sides if it's a regular polygon. Our next transformation that we're going to talk about is a reflection. And a reflection is a flipping of a point or figure over a line. You'll be told what that line is, and when you reflect a point or an image over the line, it has to be equidistant from its original point from the line. So for example, we're going to reflect point A over the line of the x-axis. So you're going to use one of your coordinate planes that you were asked to grab from the front table, glue it into your notebook, and plot the point 3, 1 on the coordinate plane. Okay, and we are going to reflect or flip point A over the x-axis. So I will highlight the x-axis for you. That's this line right here. And as you can see, point A, let's actually label it point A, is 1 above the x-axis. So if we are going to reflect it over the x-axis or flip it over the x-axis, we won't be 1 above it anymore, but we will be 1 below it. So A will be at the point 3, -1, whereas originally it was at the point 3, +1. So as you can see, when we reflect it over the x-axis, our y value becomes negative. Okay, so now you try this example. Go ahead and grab another coordinate plane and plot the point 3, 1 again. And we'll call this point point B, but we'll still have it as 3, +1. And we're going to reflect this over the y-axis. So this time we're using the vertical line y. And you will want to pause the video and see if you get the same answer as I do. Also write down the x and y coordinate. Okay, and you should have gotten that b, or we call it b prime, is -3, 1. So if you notice that when we reflect over the y-axis, it's our x value that changes. And the way that it changes is that it becomes the opposite sign of the original value. And the last line of reflection is reflecting a point or a figure in the line y = x. I don't know if you recall, but in algebra, the line y = x is a diagonal that goes straight through the origin. So this here is the line y = x. It's a diagonal that goes straight through the origin. So if we're reflecting a point over the line y equals x, we actually flip-flop our x and y values. So let's say that we had the coordinate -2, +3. Then what we would do to reflect it over the line y equals x is we would flip-flop the x and y values. So xy would become yx, or -2, 3 would become 3, -2. Okay, so let's see this in an example. We're going to reflect the points 3, -2. So 1, 2, 3, down 2, and the point 4, 5 in the line y equals x. So let's plot 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. And we are going to reflect these over the line y equals x. I'm going to draw the line in to guide you as a visual. And the rule is that to reflect them over the line y equals x, we flip-flop the x and y. So this should be -2, 3 over the line y equals x, and this point should be 5, 4. But you can also take the slope and basically do the inverse of it. So if we went to the right 3 and down 2, that means we're going to go to the left 3 and up 2 to get to our next point. And I'm going to take our next point and do it in a different color so you can see the difference. So I would go to the left 1, 2, 3. Oops, sorry, left 2, sorry. Left 2, 1, 2, and up 3, 1, 2, 3. So these points are reflected over the line y equals x. Then I would go to my point 4, 5, and I would go to the right 5 this time, 1, 2, 3, 4, 5, and up 4, 1, 2, 3, 4. So the rule is if we're reflecting the line y equals x, then we flip-flop our position of x and y. Okay, so using another coordinate plane, go ahead and try this example. You're going to reflect the points -2, 4 and 6, 3 in the line y equals x. So first we're going to plot the points. And then to give us a visual, we're going to draw in the line y equals x, which is straight through the origin, going at a diagonal. And then we're going to follow the rule to flip-flop our x and y position. So go ahead and graph those new points as they're reflected in the line y equals x. Pause the video and see if you get the same answer as I do. Okay, this should be the answer that you get. This point is at -4, -2, and this point is at 3, 6. If that's not what you get or you're not quite understanding, raise your hand and one of us will come over and help you. Okay, you should be on the exit quiz called Transformations on Kia.